This second video is on determining whether a ordered pair is a solution to a system of equations, and also paying attention to whether there's one solution, infinite solutions, or no solutions. So for the first four problems, I want you to figure out whether the ordered pair negative 1, 5 is a solution to each of these systems. There are four of them, so this is the first two and these are the last two. I want you to go ahead and pause the video now, do all four, and then turn it back on and check your answers. Okay, so to check, I'm going to say on the first one, negative 1 plus 5 equals 4. That is true. And then on the next one, x equals negative 1. Well, yes, because on negative 1, 5, the x is definitely equal to negative 1. So for number 1, it's true, negative 1, 5 was a solution to both. On number 2, I'm going to have to say 5 is equal to, I should number these, sorry, the opposite of x, which would be 1 plus 4. That is true. And then I'd have to say that 5 for the second equation is equal to negative 1/5 times negative 1. And if you did here negative 1 times negative 1, that would be 1. And then you'd have a 5 on the bottom. And so since this is not equal to 5, that means that the ordered pair negative 1, 5 is only a solution to the first equation, not to the second, so it's not a solution to the system. For number 3, I would have to say that 5 is equal to 5 for the first equation. That is true. And then for the second equation, I'd have to say negative 1 is equal to 5 minus 6, and that's true. So the ordered pair negative 1, 5 is a solution to that. For number 4, 5 is equal to 2 times, whoopsies, 2 times negative 1 plus 7, and 2 times negative 1 is negative 2, and negative 2 plus 7 is 5, so that's true. And then on the second equation, 5 would have to be equal to negative 1 plus 6. That's also true, so that means that negative 1, 5 is the solution to that system too. Okay, so now on this next set of problems, you're going to determine whether there's one solution, no solutions, or infinite solutions. Okay, so what I want you to do here is I want you to determine whether there's one solution, no solutions, or infinite. I do not want you to graph these. I just want you to look at the problems and make sure that you can explain whether there's one solution, no solution, or infinite, and be able to explain why. Okay, so turn the video off and write the problems down and make sure that you write down one solution, no solutions, or infinite, and that you can explain why. Turn the video off now. Okay, so for the first problem, you should have written that there are no solutions. These two lines are parallel, and I know they're parallel because this has a y-intercept of 0, this has a y-intercept of negative 5. They have the same slopes, so they're going to start at different places but keep going up 2 and over 1, so they'll never intersect. So, no solutions. Whoops. On number 2, there are going to be infinite solutions to this. I know that because these two problems are equivalent to each other. It's just that everything here is half of everything here. If you use the shortcuts that I was telling you about to find the slope and the y-intercept, you find the slope by doing the opposite of a over b. if you did that for this problem, then the a is 1, so the opposite of that is negative 1 over 4, or negative 1/4. If you did that for this problem, then you do 2, the opposite of is negative 2, over your b, which is 2, excuse me, I messed up on the previous problem, I was like, what? Okay, that'd be negative 1 over 1, sorry, because it's the opposite of a over b, not c. And so then that's negative 1 over 1. Here it'd be negative 2 over 2. And these both simplify, both of these, to negative 1. And then if you found your y-intercept, then you'd be doing c over b. Well, 4 over 1 is 4, and here 8 over 2 is also 4. So again, it's just another way of seeing that these are equivalent equations. It's just that all of these terms have been multiplied by 2. For problem number 3, you should have said that there is one solution. I know there's one solution because these have different slopes and different intercepts, so there's going to be one solution. For the last problem, I see that here the slope is 3/5, and if I use my opposite of a over b, whoops, then I'm going to get negative 3 over negative 5, which simplifies to 3/5, which means that the slopes on these two are exactly the same. This has a y-intercept of 0, and this has a y-intercept of c divided by b, and 0 divided by 5 is 0, and so that means that they're exactly the same equation, one written in standard form, one written in slope-intercept form, so there's infinite solutions. And this was also infinite. Sorry, I didn't write the answer. Okay, done with video number 2.